All right, welcome back. So we are looking at identities, laws and identities of trigonometry. Now, the first thing that we want to understand is that identities are probably the biggest aspect that we're going to apply in terms of trigonometry in other fields of mathematics. So this is what helps you to recognize the patterns involved with trigonometry. So now, the first identities we need to know, and these you need to practice step by step, revise, and then go back and check again. So for you to become good at things like calculus, you really have to be very good with recognition of these identities, the laws and identities of trigonometry. So the first set that we want to memorize or to remember are called tangent like that, identities, right? So what are these? We talked of one already. We said that it was tan theta is equal to sine theta over cos theta. Nothing else to know, just like this. You have to know this relationship. Okay, that's the first one that we need to know. The second one is going to be the fact that we remember from our previous discussion that we had tangent. In short, this is going to be cos theta over sine theta. You have to know, just like knowing a name of a place, name of someone, direction to a place. This is the same. There's no other science to this except the fact that this is a relationship that we worked out when we looked at the relationship between sine and cosine. Okay, we derived this in our previous one of the previous videos. So this is the relationship, the IDs, the identities that we have to know. Okay, so these are the first ones, those two, right? All right, the second that we're going to look at are the Pythagorean identities, right? So remember, we looked at the tangent identities. Now we're looking at the Pythagorean identities. What are these ones? So the first one that we are going to have to know is called sine squared theta plus cos squared theta is equal to 1. Right. This is probably the only one that you have to know because the rest of the Pythagorean identities can be derived from this one. Okay? Like which ones? We can derive tan squared theta plus 1, okay, is equal to sec squared theta. Right, so how did we come up with this? We just come up with this by dividing the first identity. Okay, we did this is equal to 1. So we divided this with cos squared theta, here cos squared theta, here cos squared theta. Right, so this is the same as sine theta squared, right? So that's sine theta over cos theta to give us tan. So hence we have tan squared theta. What about here? Here, these are same, we're going to have 1. What about there? This is same as 1 over cos theta squared. You square the whole thing. But what is 1 over cos theta? We said that the inverse of this one is not cosec. Okay, it's not similar to cosine. It's the other one, which is sec squared theta. Right? So that's how you derive this. You can also decide to divide the whole of this by sine squared theta, which means that you get a 1 here. Then here you get, instead of getting tangent, you get cot because it's cos over sine. Then this side, we're going to have 1 over sine squared theta here. So you're going to get what? You're going to get cosec squared theta. Right, so we are getting somewhere. Okay, this is the journey of knowing what these identities are all about. Right, so we have now this one and that one as our main identities that we have to know. Then the rest this we can derive from there, that we can derive from here. Even this one we can derive from that one there. So essentially, the only two that you have to know here is this one and that one. The rest you can get from these two. That is at this stage. Okay? That is at this stage. And we have to remember, right? We have to remember that sine theta, its inverse is cosec theta. Cosec with a C. Okay? Then we say that, so this will be like, we can actually say that this is, these are, well, smaller identities that you not really have to remember because you can work them out as long as you know the relationship. So cosec is equal to 1 over sine theta. So these are called inverse or reciprocal identities. But, you know, those are just names. You just need to know this one and that one. Then you have sec theta is equal to 1 over cos theta. Then we have cot, okay, theta is equal to 1 over tan theta. Right. So these are called what? These are called reciprocal identities. These ones. Okay. But here you just have to know the relationships, right? You just have to know the relationships. The ones that you have to know that form all relationships that we've looked at so far is knowing that we have sine, we have cosine, we have tangent. The first relationship between all these three is tan theta is equal to sine over cos theta. Then there's a special relationship between sine squared theta and cos squared theta. They give you 1. Then you can derive the other ones from there. These are just inverse relationships. Okay? So those are the main ones that we have to know. Okay, so now let's proceed to the next section. Okay, we continue with identities. So there's what we call even or odd identities. Okay, now these ones mean that, let's say I have sine negative theta here. Okay, if I see an ID like this, an identity like that, what will it become this side so that I can apply it to my algebra? Because I won't apply a negative angle usually. So I should know that sine, okay, is an odd sine is an odd function, okay, meaning that it will not change. It will change this side, so it will be sine theta like that. Look at the negative. It was here. It has gone outside there. So it means that this is an odd function. Okay. What about cosine? Okay. What about cosine? Cosine is an even function. So cos theta, it will give us cos theta. All right. In addition to the two that I put in red, now these are the next ones that you need to know. Right? These you have to know. What about tangent? Tangent is made up of sine and theta and cosine. Sine is odd, cosine is even. But then because we'll have a negative sign here, it means that tangent is an odd function because of sine. Okay, its relationship with sine. This will affect cot, meaning cot will be the same, right? What else? Sec. What about cosec? Let's start with cosec. Cosec comes from sine, so it will also be odd. What about sec? Sec comes from cosec, comes from cosine, meaning that sec will be even. Okay. So far, these are the ones that we need to know, right? So we are at the phase where we don't have products. Okay, we don't have products. We don't have what they call double angles, right? We half angles. Okay, half angles. We don't have these. We're not dealing with these yet. But in terms of identities that involve these singular angles, we just have to know, first of all, that tan theta is equal to sine theta over cos theta. Once we know this one, the next is we're going to know that sine squared theta plus cos squared theta is equal to 1. Once we know these relationships here, the next ones that we need to know is this aspect of angles. Which one is even? Which one is odd? What does it mean when it's odd? Okay, you have a negative angle, it affects the function. You have a negative angle, it does not affect the function. That's even. So for now, we have to know these, and then we can derive the rest from these. And then we can apply these ones here, the even or odd identities. Once we know these, we can look at products, we look at double angles, and we look at half angles. Then we can bring everything together after that. But for now, this is what we need. We'll do examples next for identities. All the best.